Hello friends, welcome to Learners Forum. Now let us go into the next set of topics, which is network theorems. So under network theorems we will have that is 9 different theorems. Under that, first let us see about the superposition theorem. So the statement of superposition theorem is, in a linear bilinear network with more than one source, which can be either voltage or current, the response across any element is algebraic sum of responses obtained from each source considered separately, replacing all the other sources with internal resistance. That is, we have to short circuit the voltage source and open circuit the current source. So the explanation about the statement is, this particular theorem is applicable for linear networks only, and it should be bilateral networks. So we have seen what is linear and what is bilateral and all in our basics session itself. And this particular theorem is applicable only when we have more than one sources, either voltage or current. So any of the sources, but it should be multiple supply. So the response across any element is algebraic sum of the response. So the statement definition is, if you have more than one sources, for example, if you have two voltage sources, let it be V1 and V2. So first you have to consider this particular voltage source alone, that is V1, and you have to get the required output, let it be output 1, and next you have to consider the second source, that is V2 alone, and you have to get the required output, let it be output 2. So to get the total output, you have to add the output 1 and output 2, which will give the output response for the entire system. So while considering in this way, whenever you have the other sources, for example, if it is a voltage source V1 and V2 here, you are considering only the V1 source, which means you have to remove this V2 source. So when you have a voltage source, you have to short circuit the voltage. So you have to short circuit this V2 supply, and in case if you have a current source, then you have to open circuit the current source. So this is the procedure for when you have voltage source and current source, and the important point is this is based on the principle of linearity. Let us see the procedure limitations, and then we can solve problems based on superposition. So to solve for problems based on superposition theorem, first is we have to consider only one source which is independent, and you have to eliminate all the other sources as we have seen in the statement. So we will definitely have multiple sources, out of which we have to consider only one source and we have to eliminate the others. That is, for voltage source we have to short circuit, and for current source we have to open circuit. And for such condition, we have to calculate the response for the circuit which we have obtained here, that is a simplified form of circuit. Then we have to consider the next source, like you have different sources available here, so for each source you have to consider the one and neglect the other, and you have to calculate the response. So you have to repeat the first two steps until you have completed for all the sources, and then you have to add all the responses that you have obtained here, which will give the total response of the given circuit. So this is the procedure to follow to solve problems based on superposition theorem. The limitations are, the power cannot be calculated using superposition theorem because power is a non-linear quantity, and it is applicable only for linear circuits only, and it is applicable to circuit with multiple sources only. Only when these conditions are satisfied you can apply the superposition theorem, and you cannot apply it for imbalanced bridges. So these are the limitations of superposition theorem. Now let us solve an example based on the procedure that we have seen in theory now. The question is, find the current through the 20 ohms resistor which is available here using superposition theorem. So the first step is we have to consider only one source. So in the circuit we have one voltage source and one current source. So totally we will have two sources. So we have to consider the voltage source alone for the first step, and you have to calculate the entire response. And for the second condition, you have to consider only the current source, and you have to neglect this 20 volts and calculate the total response and add the two responses. So first thing is we will consider 20 volt source only, which means you have to remove this particular current source. So as we have seen, whenever we have a current source, we have to open circuit the current source. So if you open circuit, you will get the minimized circuit as, first we will have a supply which is 20 volt, followed by 5 ohms resistor. Again we have 10 ohms resistor, a 20 ohms resistor, and in between we have 10 ohms resistor. Here it will be open circuited, so we can neglect that, and the remaining minimized circuit will be in this way. So here we have a node and let it be V1. So the nodal voltage V1, and we can write the nodal equation for this particular node V1. So we will get V1, we have a source here. So V1 minus 20 divided by R value is 5, plus across this branch it is V1 divided by 10, plus across this branch it is V1 divided by 2 resistors are connected in series. So 10 plus 20 will be 30, which is equal to 0. Solving this, we will get 6V1 minus 120 plus 3V1 plus V1 divided by 30, which is equal to 0, which means 10V1 will be equal to 120. So the value of V1 will be equal to 12 volt. So this is the value that we have obtained in the first consideration. We are supposed to calculate the current through the 20 ohms resistor. So across this particular branch, we are supposed to calculate the value of current. Let it be I1, which is equal to V1 divided by 10 plus 20. V1 value is 12 divided by 30, which is equal to 0.4 amperes. So this is the value that we have obtained under the first consideration. Now let us consider the second source by removing this particular 20 volt, that is we have to short circuit the voltage source. So the second consideration is consider 4 amperes, that is current source, and eliminate, that is short circuit the voltage source, that is 20 volt. So then the circuit will be, after short circuiting, it will be in this way. We have the same resistor and we have a current source of 4 amperes. So this will be our minimized circuit. So here we have got 5 and 10 as parallel and series with 10. So 5 parallel with 10, series with the 10 ohms resistor. So it will be plus 10, which is 5 into 10 divided by 5 plus 10 plus 10, which is 50 divided by 15 plus 10, which is equal to 10 by 3 plus 10, which is equal to 40 by 3 ohms. So applying the current division rule, because this current is getting split in this way and this way. So applying the current division rule, we will have the value of I2. Since we are considering it for the second source, we can terminate it as I2. So I2 is equal to source current Is into the resistor value R1 divided by total resistor. So R1 plus R2, which is equal to current source is 4 amperes into R1 value is 40 by 3, that is this entire thing, divided by total resistances. So 40 by 3 plus the other value is 20. Solving this, we will get 4 into 40 by 3 divided by 40 by 3. Solving this, we will get 4 into 40 divided by 100, which is nothing but 1.6 amperes. So the total response, that is current, will be I1 plus I2. I1 we have got it as 0.4 and I2 is 1.6, which is equal to 2 amperes. So this is the current flowing through 20 ohms resistor.